Alright, so the last thing that we talk about in 4.4 is a special type of application of the definite integral in the fundamental theorem of calculus. And it's actually a very important one. We only, again, hit the basics of it, but average value is important, right? Your grades are based on averages, right? When you want to find your average test score or quiz score, you add up all your quiz scores and divide by however many they are, right? If you have 5 quiz scores, you add up all 5 and divide by 5. Alright, well, a function, when we want to find the average value of a function, so suppose I want to find the average value of profit from month 1 to month 5, well, I would have to add up all the profit values between 1 and 5. And since it's a function, there are infinitely many values between 1 and 5. And so we do that using the definite integral, right? The definite integral can find the sum of all of the function values between 0.1 to 0.5. Then we have to divide by the total, and as it turns out, the division part, this is infinitely many, you can't divide by infinity, but as it turns out, we're divided by the change in my x values. That was what we divided by. I'm going from x1 to x5, so I'm going a distance of 4 units. What's the average value of my function over those 4 units? And so to find that, you divide by your change in x from your lower value to the upper value. All right, so the average value of function is this expression. All right, it's 1 over b minus a. This is the division part. 1 over the change in my x from b to a. And then remember, this is the accumulation function. This integral means I'm adding up all of the function values from point A to point B. Right, that's the sum part. And then the divide by b minus a. That's the division part. I divide by the distance we cover when we summed up those y values. All right. So either memorize this or put this in your notes. The average value is adding up the function value, which is the integration from a to b. The division part is you divide by b minus a, right, which instead of writing divide by, we write it as multiplied by the fraction 1 over b minus a. Another way you can rewrite this, and again, the book talks about this in their video, so make sure you walk there. They go in more detail exactly where it comes from and kind of explains the why behind it. Another way you can rewrite it is you can take your function's average, multiply it by that change in difference between b minus a. And this is actually the form that's easy to prove than the first form. Equals that area under the curve of my f of x from a to b. All right, we're just going to, again, you just have to memorize that this is the average value of the function, is integrating from a to b, and then multiplying by the fraction 1 over b minus a, which again is the division part. I'm dividing by the change in distance from b to a. All right, so I'm going to do a couple of examples. Again, it's just solving it. You may solve these on the calculator, but you need to make sure you set it up carefully. So we want to find the average value of the function over the interval 0 to 4. So I want to know what's the average y value, right, the function value, the y value of this particular function between 1 to 4. All right, well, the average value is found by taking 1 over b minus a, integrating from a to b of my function f of x dx. So in this case, a is 0, b is 4. So when I find my average value, I'm going to take 4 minus 0, integrate from 0 to 4 of my 4x minus x squared dx. And so my average is 1/4, integrating that function. Alright, so I'm going to solve this on the calculator. Can't forget, though, the multiply by 1/4. So don't forget there's a 1/4. The 1/4 has to do with the averaging part, right? Whenever you take an average, you add up your scores and divide by how many. That 1/4 is the part that's the divide by how many. In this case, it doesn't represent how many because there's infinitely many. It represents the distance I'm moving, right? I'm looking at the function over 4 units. Specifically the 4 units 0 to 4, but that's the piece of the function I'm looking at. I'm integrating, I'm finding the average value between those 4 units, all right? And so you do that. So I'm going to solve this graphically. So again, you would graph the y equals 4x minus x squared. Find its area between 0 to 4. So again, I'm going to go here and clear this out. Make sure I type my function in right. So 4x minus x squared. I'm going to go back to a zoom standard. So I'm going to hit zoom standard to go back to a standard window. Alright, so there's my function. 0 to 4 is this piece where it's all above, so it should come out positive. So I hit second, trace, integrate from 0. So, integrate. Second, trace, 7. I want to skip the hit 7 part. Alright, sum of my area is 10.6666. So remember what that is. That's 10 and 2/3. Since I want my answers to be exact, I'm going to write 10 and 2/3. Or again, 10 and 2/3, if you hit the math key, fraction key, that's 32 over 3. So it's 1, don't forget the 1/4, because that's important. 32 over 3, which simplifies to 8/3. And that's exactly what it is. 8 divided by 3, and so we want exact answers, right? We don't want the decimal approximate. So that's why sometimes these actually might be easier to do by hand, because graphically, you don't actually usually get the exact answer unless you can kind of convert it like I did with the... I know most of ours are thirds, so it's usually 1/3, 2/3, or something with a third in it. So the function average is 8/3 from 0 to 4. Now that's just its average, meaning if you go look at the function, all right, 4/3, if I graph 4/3, or 4/3, 8/3, graph. Alright, it's actually, again, it's the middle value, right? Some of the time the function's higher than it, sometimes low. Actually, it's the same as it twice. And it will always at least be the same as it at least once. Sometimes it's more than once. In this case, it's twice. So remember, it's the average. It's averaging all of the function values between 0 to 4, and it averages out to that 8/3. When it takes all of these, which are actually lower than it, all of these, which are higher than it, and it, again, it's like your test scores. You get an average of 82, but some of your test scores are higher than that, some of your test scores are lower than that. It's the average that's 82. The same thing here with this function. Between 0 and 4, some of the values are higher than 8/3, some of the values are lower than 8/3, but when I add them all up and divide by that distance, that's what its average is. Its average is 8/3. Alright, we'll stop there and we'll pick up the next example in the next video.